Here we go. Oh no. For the last time. Oh, Miss Ann. Sorry, I got something in my eye. You said allergy or something. I'm okay. Okay, let's keep going. Number 1 says this: how much work would it take to stop a vehicle? My first thought was, well, work equals force times distance. That's always my immediate go-to because it's the least amount of, no pun intended, work. Don't see a force or see a distance. I've told you on your test tomorrow, Thursday, I won't be putting force versus distance graphs. I decided to bump that more to Physics 12, but that would be the next thing I would look for because that's also not that much work. Don't have that. So it's going to be the work energy theorem. It's the change in potential plus the change in kinetic. This question to me wouldn't make it on a test because I should have said something like over a level road. We have to assume that we're on a level road. I'm not wild about that, so I'll have to change that for next year. Paul, what's changing anything? So this is going to be a half mv final squared minus a half mv initial. It's ke final minus ke initial, but I did substitution. I noticed that we come to a stop. In fact, you're going to get a negative answer here, which you should. The car needs to lose energy. It's going to be negative work. When I crunch the numbers, I'm going to get 0.5 times 900, negative 0.5 times 950 times 45 squared. This is going to be a pretty big number. I'm doing some rough math. Stop dropping stuff, thank you. I'm doing some rough math. I'm getting something in the 800 or 900 thousands, I think. Maybe I'm off. You get negative 962,000, negative 961,875, negative 962,000. If you missed the negative, I would take a half mark off. This is why you don't want to get hit by a car, because if all of the energy got transferred to you, that's not a good thing. Now, there's no way you would bring the car to a stop, but it's got enough energy to do some serious damage to you if your body has to absorb all that. It would apply a force times distance on your rib cage and on the bones in your body. Not good. What's the minimum force of friction? So now I'm going to say, well, honestly, I'm starting out, Bryce, by kind of thinking work equals work. I'm saying force times distance equals negative 962,000. Bit of a problem because on the left is negative, on the right isn't. But wait a minute. The car is traveling forward. This force is friction. Which way is friction pointing? Backwards. For the force times distance work equation, how could I show that the force and the distance were in opposite directions? What would be a clever way to show that? In fact, technically, there is an implied negative right there. I do have a negative on the left, a negative on the right. It's really, Madison, the negatives cancel. And I'm going to do that on my next line. On my next line, I'm going to say, okay, the force of friction equals 962,000 divided by the distance, the 150. I'm going to use my answer button. And I get... I'm going to ignore the negative now, 6,412.5. So I'm going to write friction equals 6,410 newtons, 412.5 newtons. Oh, and I also knew not to go friction equals mu times the normal force because I didn't see a mu. In fact, part C is saying find the coefficient of friction. Well, if friction equals mu times the normal force, I think mu equals friction divided by the normal force. It's going to be 6,412.5 divided... Oh, I don't know the normal force. I think in this case, I don't see any extra vertical forces. I think I can reliably assume it's mg. And so if I crunch that, answer button divided by bracket m, what was m of the vehicle? 950? 950, Mr. Duke, times g. and I get a coefficient of friction, again ignoring the negative, of 0.689. And no units. You something wonky there?
No.
Oh, thought you said a bad word for a second there. So for these ones, 1 mark for each of them. They're mostly plug and chug. You have to do a tiny bit of work for B, but eh. Number 2 is going to be worth more. I'm going to start out, you didn't have to write this, but I'm going to start out again by saying work equals work. I'm going to start out by saying force times distance equals the change in potential plus the change in kinetic. I don't see any sign of a hill, so I can do that. I'm going to get a half mv final squared minus a half mv initial squared. That equals force times distance. Bryce, what's the final speed of every car accident ever? So, gone. Now, that's going to give me a bit of a problem. That's going to give me, on the next line, a negative a half mv initial squared and a positive force times distance. But just like before, Emily, are the force and the distance in the opposite directions when you're hitting the brakes? Say yes. There is an implied negative right there, so I can get rid of the negatives on my next line, and I'm going to do that. This wants me to find the speed. I think I would times by 2, divide by m, square root. I think I would take the force of friction times distance times by 2, divide by m, square root. That equals v initial. Problem, I don't know the force of friction. Friction is what times what? So I think I can say 2 mu times the normal force times distance over m. I don't know the normal force. Is it mg this time? So you're telling me I can go vi equals the square root of 2 mu mg times d over m. And one nice thing is, hey, the masses cancel, which is good because the RCMP doesn't even know the type of car that was involved. They don't know the mass. There was no witnesses. But they can at least start trying to trace this person, and once they find the car, they can compare their numbers as well. I'm going to get 2, what's mu? I don't know what's mu with you. 0.55 times 9.8 times 52 over nothing. In fact, I didn't need to write a great big square root symbol. I could have just done that. It's going to be 2 times 50 point times 0.55, Mr. Dewick, times 9.8 times 52. That's crazy fast. Oh, square root. And I get 23.7 meters per second. That's a tough question. If you got that, 3 out of 3. Otherwise, I would probably give you a half mark if I saw that line right there, a half mark if I saw that, a half mark if I saw that, a half mark for that, a half mark for that, and a half mark for the answers. Number 3, a lot of people were telling me they had trouble with this. I like this question. I like this question. I like this question. We have a change in height, change in speed, Emily, yucky, curvy path. It's going to be conservation of energy. I'm going to make a little note here. That's initial, that's final, and it's going to be kinetic initial plus potential initial equals kinetic final plus potential final. I've had a bunch of people ask me, Mr. Dewick, how do I know when there's 0? So KE is 0 when V is 0, when you're at rest. Are we at rest at location A? No. Are we at rest at location F? No, because they're asking me to find the speed. So those aren't 0. PE is 0 when on the ground. If we're talking about gravitational potential energy. Not all potential energy is gravitational. Some of it can just be force times distance. Oh, you know what? I think they've measured the height from the bottom of the slide, so the ground is right where I've drawn that black line, so I can say that. I'm going to get a half m v initial squared plus m g h initial equals a half m v final squared. Diego, is there an m in everything? Can little kids and grown-ups go on the same water slides? Because mass cancels. Now, they do have separate rides for kids, but those are just tamer. They're not as steep. Grown-ups can still go on them, and they'll make it just fine. What am I trying to find, Diego? Which fast? Initial or final? Pretty sure initial is 8.3. Try again. Okay? I want to get that by itself. I showed you all a clearing the fractions trick where I just went times by 2, times by 2, times by 2. And I like that, but in talking to a few of you, that creeped some of you out. So there's another way you can do this. What's 1/2, Madison, as a decimal? You can just go like this. Divide everything by 0.5. That's going to give you VF squared. How to get rid of a squared. That'll work. It's a slightly larger amount of typing that you'll do than clearing fractions, but you'll get there just fine. That's probably the easiest way to get there. Not the cleanest way to get there, but the easiest way to get there. Because then you'll get this. VF equals big square root symbol, 0.5 times 8.3 squared plus 9.8 times 21, all divided by 0.5. I'll type what's inside the square root first. 0.5 times 8.3, don't forget the squared, plus 9.8 times 21, close brackets, divided by 0.5. Square root, answer button. And I get 21.9. If you said 22, I'm fine with that, but don't round off on the next question. 21.9 meters per second. By the way, times by 3.6, that's a screaming fast water slide. I just made up some numbers, but that's a scream. You're going almost 80 clicks in a water slide. There's not that many out there where you're going that fast. So I would go on this, but I think I would also be making sure every piece of bathing suit clothing that I was wearing was tightened up, and I might maybe even wear it if I was a male wearing a shirt on this, because I'd be worried about taking the skin off my back on those little ridges that they have with the way they connect the water slide. I'm assuming all of you have done a day at the water slides at least once and found, hey, my back is sore by the end of the day because you've got some scrapes on your back, right? Every once in a while things don't go quite as planned. But I'd still go on it. It'd be great. There was a bit of a built-in error check because B says, suppose the child is only going at 16 meters per second, which kind of implies you got an answer bigger than 16 for part A. So when I saw that 21.9, I kind of smiled and said, I'll bet you that's right. How much energy was transformed into heat? So it's still going to be conservation of energy, G. But now we're going to add heat. We can still say that's 0, but the rest isn't. They want me to get the heat by itself. I guess I'll minus that over. I'll get KE initial plus PE initial minus KE final, and I'll put the heat over on this side by itself. That equals heat. .5. Let's not put in numbers yet, Mr. Duick. A half mv initial squared plus mgh initial minus a half mv final squared. Now, Diego, the masses don't cancel. A little kid won't generate anywhere near as much heat as a big grown-up. It's going to be 0.5. How much was the kid's mass? 45 Oh, too far. 8.3 squared plus 45 times 9.8 times, was it 21? I think it was 21. Minus 0.5 times 45 times 16 squared. You get 5,051? I'll write 5,050. And that's heat energy in joules. I forgot to do part marks. So for part A, I would go 1 mark for that, 1 mark for that, 1 mark for the numbers, and 1 mark for the answer. For part B, I would probably go 1 mark for that, 1 mark for that, 1 mark for the numbers, and 1 mark for the answer. But if you got it right, 4 out of 4. Oh, let's ride a roller coaster. I think that's going to be initial, that's going to be final. Some of you may have noticed this is actually the same question that I gave you in the notes, so you got the same answer. It'll be a different question on the test with different numbers, but it'll be the same procedure. There's a change in height, change in speed, yucky, curvy path. I'm going to start off with conservation of energy, G. Are any of these zeros? Yeah, it does say we're starting from rest, so I can say that. And we're definitely on the ground, so I can say that. This gives us a much, much cleaner equation. I'm going to end up with mgh initial equals a half mv final squared. Paul, can little kids and grown-ups go on roller coasters? Why? Well, that's kind of nice. It wants me to get the v by itself. Okay, I'm either going to ask you to find the v or the h. How would you get the h by itself? How would you move the g over? Divide. V times by 2 and then square root. There, that's the two big ones. So I'm going to go v final equals 2g h initial square root. Instead of timesing by 2, you could also divide by 0.5. Same thing. 2. I think this one worked out dead even, didn't it? Yeah, 42. Good coaster, though. Half mark for that. Half mark for that. Half mark for that. Half mark for that. I can't remember if I told you this story or not. You notice when I'm marking things, I put little 0.5s everywhere. I do that when I make up answer keys for your tests as well. So a few years ago in Math 12, Mr. Kamosi and I were team teaching, and there was a student in his class that had stolen my answer key for the trig test. And we knew the kid had stolen it because on his answers, he had the 0.5s all over. He didn't know anything. He just memorized what the pages looked like, and he had my marking scheme there. Did I tell you that story? I did? Okay. Don't cheat. You suck at it. B. So for part B, Sarah, I have two options. I can let the ground be that high. I can let the ground be that, pretend that's 0, and make the height of 40, and that'll look just like this, but the h will be 40. I had a few of you during Flex saying, I don't find that very, very comfortable. So what you can do is you can let that be that height. Now, if you want to, you could let this be initial and that be final. The only risk here is you're going to use your answer from A to find B. But as long as you're right on A, you're okay. It's still going to be conservation of energy. G. Now, again, full disclosure, Joanna, I wouldn't do it this way. I would have just said, I'll let the ground be there because it's less work. But this is probably the easiest, most systematic way to get there. Now your initial potential energy is 0. It's going to be a half mv initial squared equals a half mv final squared plus mgh final. They want me to get this v by itself. The m's still cancel. I could clear fractions. I could multiply everything by 2. But if you don't like that, you can just go, okay, 0.5 v initial squared minus gh final divided by 0.5. That equals vf squared. And then Madison, how they get rid of a squared? That'll get you there. It's not the least amount of writing method, but that's probably the easiest method to get you there. And now it's just going to be plug and chug. It's going to be the square root of 0.5 times 42. I would use my answer from part A. Minus 9.8 times 50. All divided by 0.5. Need a bracket, Mr. Dewick. 0.5 times 42, don't forget the squared, minus 9.8 times 50, close off the top, divided by 0.5, square root of that. This will also work out evenly, 28 meters per second. If you got that right, 3 out of 3. Otherwise, I would probably give you 1 mark if I saw that. 1 mark if I saw some version where you got the v by itself. 1 mark for the answer. If you did the 50-meter trick, letting the ground be 50, you would have v final equals 2ghi, and you would have just put a 40 in there and get the same answer. So on your test, there's either going to be a slingshot getting pulled or a bow and arrow getting pulled. It's the same physics. We're doing, first of all, work. First thing I noticed, nice try, Mr. Dewick, 0.7 meters. Work is going to be force times distance. It's going to be 130 times 0.7. 91? No? Yes?
Yes.
Yeah, okay. Declan, how much potential energy is stored in the boat? What can't I use?
You can't use MGH.
Why can't I use MGH? Isn't that potential energy? Well, that's gravitational potential energy when you change the height. Look at the picture. I haven't changed the height. So how much potential energy did I store?
91.
Oh, is that why it was 1 mark? It's the same answer as A. You've done work on the object. You've stored energy in it. Assuming the arrow has a mass of, nice try, 0.0186 kilograms. What's the maximum speed? I could do a full conservation of energy, but I think the argument here, Declan, is all of the stored potential, initial, the 91, turns into kinetic final. In other words, I'm going to say 91 equals a half mv squared. M does not cancel here. Times by 2, divide by m, square root. Times by 2, divide by m, square root. Times by 2, divide by m, square root. And I get 98.9. Which seems reasonable. A bow and arrow. An arrow would go very fast, but not crazy fast. Also, the bonus suggests that if we lost energy, we'd be going 54, so I figured it's going to be bigger than 54 meters per second. If you got that right, 2 out of 2. Otherwise, I would give you a half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. How much energy was lost to heat? Okay. Kinetic initial plus potential initial equals kinetic final plus potential final plus heat. The final potential is 0 because when you let the bow go, all of the stored energy vanishes, and it did start at rest before you let it go. So I guess the heat is going to be the initial potential energy, 91, minus a half mv final squared. It's going to be 91 minus 0.5 times 0.0186 times 54 squared. 91 minus 0.5 times 0.0186 times 54 Don't forget the squared. Did y'all get 63.9 joules? Of heat. This quiz is out of 23. You can get 24 out of 23, but unfortunately the software won't let me give you the bonus mark. So even if you get 24 out of 23, on the printout you'll get 23 out of 23 because the software is stupid.